Hi there, I'm Christopher Geib, and this is the teaser talk for our paper titled Planning Using Combinatory Categorial Grammars. Since the point of this video is to convince you to either read the paper or better yet, talk to me about it, and this video is supposed to be less than 5 minutes, I won't discuss how our planning algorithm actually works or any of the serious technical meat of the paper. Instead, I just want to present the motivating idea, set it in context, and discuss some of our results. And then you'll have to come talk to me and read the paper and find out how we did it. So let's get started. There are well-known claims about a tight relationship between reasoning about actions and natural language processing. In general, these claims rely on our intuitions and some evidence from developmental psychology that suggests human skills in the area seem to develop in lockstep. However, these intuitions and experiments don't provide an algorithmic or a computational account that links these two research areas and that would allow us to build systems with both capabilities. One way to do this would be to show that the representations and algorithms from natural language processing can be used to explicitly reason about actions and solve problems that have previously only had their own representation and algorithms in the planning literature. Over the last several years, to provide exactly this algorithmic linkage, working with a number of colleagues and students, I've explored how to perform plan recognition based on viewing the problem as one of parsing a formal action grammar, much like natural language processing. In this work, we've used probabilistic combinatory categorial grammars, or CCGs, a learnable functional grammar formalism explicitly developed and used for incremental natural language processing. Using research on natural language parsing, we have successfully shown that CCGs can be effectively used for probabilistic plan recognition. We've also produced initial results demonstrating that the required CCG action grammars can be learned. This represents two significant steps forward in linking natural language processing and reasoning about action. The next step in building this linkage is to show that CCGs can be used for planning. This paper presents this next step. It formulates the planning problem in terms of CCGs. It provides an algorithm for planning directed by CCGs. It proves soundness and completeness for the algorithm. It discusses relationships to HTNs and provides initial results that show the algorithm's performance is comparable to that of other state-of-the-art hierarchical planners. It does all of this with the exact same grammars that are used for performing plan recognition, and the same kind of grammars and parsing algorithms that can be used for natural language processing. There's been a great deal of work on the expressiveness and complexity results relating context-free grammars and hierarchical planners. The subtype of CCGs that we've used has a context-free expressiveness. This means that our system is more than able to produce plans with context-free expressiveness. However, because there are multiple CCGs that are equivalent in yield to a given context-free grammar, and as we've shown in our prior work, these yield equivalent CCGs have very different performance for recognition. We've not provided an algorithm for converting a CCG to a CFG or an HTN, the closest planning model to our work. And we've left this as an area for future work. As an extra incentive to come talk to me, I'll point out that the notation and ideas behind CCGs are very different than context-free grammars. And our formulation of planning does have a number of differences with HTNs, HGNs, and even non-hierarchical planning. I'd be thrilled to have you stop by our poster and discuss these ideas and welcome feedback about how we can make the ideas in this work and progress more transparent and more compelling. I look forward to seeing you at the poster presentation.